Okay, this starts the new material, Chapter 2, Section 1, which is all about angles and their measure. So if I have a portion of a line, so I have a line that starts at a particular point V, because you'll see we call this the vertex, and it extends indefinitely in one direction, that's a ray. That's all a ray is. If I get two rays, so I get another one, and they're connected at that vertex, then they form an angle between them where I have the initial side, and then where it stops becomes the terminal side. If I go in a counterclockwise rotation, which I kind of giggle that I don't know if students know what clockwise means anymore with all this technology and everything digital, but counterclockwise, okay, so rotation, that's a positive angle. If I go clockwise, then that's a negative angle, probably different than what you would think, but that's the way it's set up. And so as you can see here, I have three different examples, shows the vertex connects these two rays. We have the initial side, we go the distance of a particular angle, and then it stops at the terminal side. On this one here, it can look like the same angle, but in this case, if I go in the negative direction all the way around in the clockwise, then this is a negative angle. And finally, the last one, I actually could start at the initial side and go all the way around and then back up to the angle. And you probably saw in that last example, whenever we denote angles, we use lowercase Greek letters. Just get some used to these of alpha, looks kind of like an A, beta, B, gamma. Don't use this one a lot in this class. You probably will see it used a lot more in your calculus classes. And then theta. So alpha, beta, gamma, theta, these are just way that we represent angles. Just like in algebra, you used x and y to represent variables. We say that an angle is in standard position if the vertex is at the origin. So there's origin right there. There's origin right there. And so I start with an initial side, and then I go whatever distance of my angle, in this case theta. Wherever it stops, that becomes my terminal side, and I can say this is in standard position, and then even look further to see what quadrant my terminal side ends up in. So that's something like these examples. You could end up in a quadrant, like quadrant 2. Remember in the review we talked about quadrants, or quadrant 4. Or you could have a quadrantal angle. That means your terminal just lies on one of the axes. So you have to have a calculator. It can't be a TI-83, all that stuff, high up stuff that you can graph with. This is a non-graphing calculator, scientific calculator. Typically, most students get something like the TI-30X. And the big key here is you're going to see that when we measure angles, we're pretty comfortable with degrees, right? You know what it means for something to be 90 degrees. You know, 360 degrees, that's when you spin out, right? When there's water on the road. But then in math, we typically use radians. This again is, you know, kind of the same thing as saying, well, miles versus meters. These are just two different ways to measure angles. Your calculator has to be in whatever mode you're working in. And typically it'll say mode, and you'll have to switch it back and forth from degrees to radians. So you might have to Google that to look it up, or if you're by the school and you have your calculator, come by, see me, ask somebody in the tutoring lab. Just let me know, but this is very important. There will be a lot of times that I'll say, is your calculator in radians or is it in degrees? And then once again, you're going to see that the majority of this course, we're going to deal a lot with radians. All right, if I go all the way around, I have two rays here. They're just on top of each other. My initial side, and then I come all the way back around to my terminal side, I've went 360 degrees. We call that one revolution. If I take a fourth of a revolution, so I just take a fourth of 360, that's our 90-degree angle. If I do half, then that would be 180, and that looks like this straight line here, the straight angle of 180 degrees. So you need to be very comfortable with looking at and being able to draw angles. So let's try some of these. Let's see if I can get my pen working here. And if I want to draw something, and we're going to make all these in standard position. So if I want to draw, let me get another color, 45 degrees. Well, I know all the way to the y-axis is 90 degrees. So if I cut it in half, that would be my 45 degrees where I have my initial starts on my x-axis. This is in standard position with my vertex at the origin. And I just cut the 45 or the 90 in half, and that gives me 45 degrees. All right, now what if we want to do -90? Well, I know to the y-axis is 90, but if I'm going in the negative direction, I'm going clockwise, so that would be -90. All right, next one, 225 degrees. Get me into the color here. I know all the way around is 360, so I'm not going all the way around. I also know all the way to the other side of the x-axis is 180. Well, if I add 45 more, so again, starting my initial, and go all the way to 180 plus 45 more degrees, then that gets me to 25 degrees. All right, and then the last one is if I want to go 405 degrees, my initial always starts here. I go all the way around is 360, and then 45 more would give me my 405 degrees. So it might seem kind of silly to look at drawing these angles, but this is something you need to know how to do and understand about what angles look like and their degrees. And so then we'll have things that we measure, like GPS systems that are measured in degrees, minutes, and seconds. And we can convert these, and let me mention the symbols here, the degree symbol, the one little tick mark for minutes, 2 for seconds. We can do conversions here where we can say, well, 1 minute equals 1/60th of a degree. 1 second is 1/60th of a minute, or 1/3600th of a degree. Once again, counterclockwise revolution all the way around is 360 degrees. If you only go 1 degree, just barely, that's the same as 60 minutes. And then once again, 1 minute is the same as 60 seconds, which is the same that we're used to. So if I want to do a conversion here, I want to convert, I have a degree and minutes, and I want to put it all in degrees. So what I do is I get the degrees together, and then I separate the 30 and multiply it by 1 degree, because 30 times 1 degree would be my 30 degrees. Well, then if I go back and I look at that previous slide, we said that one degree is the same as 1 minute is the same as 1/60th of a degree. Okay. My mistake, sorry, catch that, got to match that. So 1 minute is the same as 1/60th of a degree. Well, now everything's in degrees, so I can just simply multiply this straight across, which is 15 degrees, and that's 1/2. So 15.5 degrees would be my answer. If I want to convert something that's all in degrees into minutes, now here I would take my 32, which is in degrees. I would take the 0.25 and then multiply it by 1 degree, because this is all in degrees. So I have 32 degrees times 0.25. And I want to go to minutes. Well, we said 1 degree is 60 minutes. And multiplying this straight across, I'm going to get 32 degrees and 15 minutes. So just multiplying those two. So that's a good stopping place because we're going to kind of move into something a little different next, but to get you through the first part of this. So practice doing the conversions, practice drawing and recognizing angles when you see them.